slide. So the course flow will be both theoretical and practical information. We will learn a specific pattern, why and where we should use. After that, we will see reference architectures. After that, we will design our architecture with applying these newly learned pattern and principles. And lastly, we will decide which technologies can be chosen for that architecture. And at the last sections, we will make code review for existing microservice architecture GitHub repositories. And for practical implementation, we will see some codes and implement code reviews on these microservice repositories. So this course will include hands-on design activities, iterate design architecture from on-premises to cloud serverless architectures, and evolves architecture from monolithic to event-driven microservices and serverless architectures, refactoring system design for handling millions of requests for high availability and high scalability, and applying best practices with microservices using the design patterns and principles. We will examine microservice patterns with all aspects for vertical considerations like communication, data management, caching, deployment, resilience, and so on. And this course will prepare you for software architecture interviews and for system design architecture interview exams. So with this course, you will gain real-world experience about all architecture positions from monolithic to event-driven microservice architectures. This course prepared for the beginner, but at least you should be familiar with the basics of software architectures. This course will have a good theoretical information, but also will be 90% hands-on design activities. All course architecture steps will design step by step and together. I hope you will join me on this journey and design architectures with me. In this video, we are going to learn architecture design journey. Over the years, software development moved away from traditional monolithic architectures because of the complexities with tight coupled and interconnected code. As a result, of requests, step by step and together, I hope you will join me on this journey and design architectures with me. In this video, we are going to learn architecture design journey. Over the years, software development moved away from traditional monolithic architectures because of the complexities with tight coupled and interconnected code. As a result, microservices are adopted many projects with using cloud-native approaches that enable distributed computing through multiple smaller services. So this course is a step-by-step process for software system design and evolve from monolithic application to the microservices following the pattern and principles. Design architecture from on-premises to cloud serverless environments, and we will evolve architecture monolithic to event-driven microservices, refactoring system design with step-by-step and handling millions of requests services. You can see the image on the slide. We will start with the monolithic architectures, that is including the microservices, where all business services are deployed. Microservices, which including the independently developed, deployed, and managed communications with loosely coupling services. And lastly, we will evolve nanoservices. Nanoservices are designed to perform single function, so the output is exposed through a specific API endpoint and perform a specific task. So the question is, when we start any application, which architecture approach we should choose? Monolithic, microservices, or serverless? So we will see during the course, but there is no default answer for this question. It all discusses vertical considerations of our architecture, and we will discuss microservices with all aspects. These are the microservices building blocks, which is the microservice decomposition, breaking down microservices, communications, synchronous transactions, distributed caching. We have deployments with containers and with different aspects of the microservices pillars. In this video, we are going to learn way of learning, and after that, we will learn architecture approaches, patterns, principles, and best practices related to the problem. And after that, we will feed communication, we will learn microservice communication patterns. Another problem is inter-service communication makes heavy load on network problem with learning new stuff. And this process will start for every problem, increase traffic, handle more requests. We will solve this problem with applying vertical and horizontal scaling. And second problem is breaking down application into microservices. We will solve this problem with learning microservice decomposition patterns. And another problem is direct client to service communication. To avoid this communication, we will learn microservice communication patterns. Another problem is inter-service communication makes heavy load on network traffic. To avoid this traffic, we can use gRPC technologies. Another problem comes from the business teams required chat with support agent on our e-commerce application that we solve this problem with using WebSocket APIs. Another problems that you can see service-to-service communication chain queries. To avoid this situation, we will use service aggregator pattern. Another problem is long-running operations can't handle with synchronous communications. To solve this, we will use asynchronous message-based communications. Another problem is database bottlenecks when scaling different data requirements for microservices. To solve this, we will learn CAP theorem. Another problem is cross-service queries and write commands on distributed scale databases. To solve this, we will learn data patterns, which including CQRS, materialized view patterns, and event sourcing pattern. Another problem is manage consistency across microservices in distributed transactions. To solve this, we will learn Saga pattern, transaction output patterns, and so on. And another problem is handle million of events across microservices. To solve this, we will learn event-driven microservice architectures. One of the microservices is transaction and patterns, which is on distributed scale databases. To solve this, we will learn service queries. And another problem is to solve this, we will use asynchronous message-based communications. Another problem is database bottlenecks when scaling different data requirements for microservices. To solve this, we will learn CAP theorem. Another problem is cross-service queries and write commands on distributed scale databases. To solve this, we will learn data patterns, which including CQRS, materialized view patterns, and event sourcing pattern. Another problem is manage consistency across microservices in distributed transactions. To solve this, we will learn Saga pattern, transaction output patterns, and so on. And another problem is handle million of events across microservices. To solve this, we will learn event-driven microservice architectures. One of the problems is database operations are expensive, which is low performance. To solve this problem, we will use distributed caching strategies. Another problem is deploy microservices at any time with zero downtime and flexible scale. To solve this problem, we will learn containers, orchestrations, and Kubernetes-related patterns. So these are some of the problems that we will solve during the course. In this video, we are going to start how to choose right architecture and better than others. Here you consider monolithic architecture, applications, non-functional requests for your application, and to self. When you apply and lose benefits of your application nature, like easy to develop requirements, after that we should define our limits, constraints, and assumptions of the application and define business requirements like scalability, availability, and latency. These requirements will reflect our traffic burst or steady workload, what level application outage is acceptable for our case. So all these questions are very important to drive these that drive our design considerations. Because if there is no business problem or any problem can't relate it to business, means you are. In this video, we are going to talk about how to follow the architecture with finding new problems. Let me repeat. In some, this is reference architecture course that you can take any part of the course using the Draw.io tool. Hope you can get benefit and you. In this section, we are going to understand e-commerce domain, and we will see design with following the course flow, which start with the problem, web application, identify use cases, and these should be available 24 hours and 7 days, and this should handle good amount of requests per second. And these application requirements, we will start with understanding the function requirements. In this video, we are going to e-commerce application. So we will understand e-commerce domain with all use cases and focus on the functional requirements. It doesn't matter to understand what you will develop, and it is crucial that defining your use can put all together into object interaction diagram, and this diagram would be our potential microservices if we choose the microservice architecture. But now we will start with a small e-commerce application that's and order item history. Now let's identify list cost items in the shopping cart, apply coupon for discounts, and see total cost items in the shopping cart. Check out the application use case item. The user, I want to filter products as per brand and categories. As a user, I want to check out the shopping old orders and order items domain and write down. In this video, we are going to usability and efficiency. Scalability and reliability are measures of, however, it would have been absolutely impossible. E-commerce application should develop several years, and usability and efficiency, e-commerce application should respond acceptable latency like less than 3 seconds. That means short response latency time. Okay, let's talk about acceptable latency now. How can we make our application for acceptable latency if our application gets use more and more users? Please see the table in here. We have, as per you can see the table, we will start with e-commerce application that gets only, and we will design when our business grow and grow, it will require more resources to accommodate bigger request counts, and we will see, as you can see that, so according to our functional and non-functional requirements, we are going to design our first e-commerce application architecture. In this section, we are going to learn monolithic architecture. There are many approaches and patterns that evolved over decades of software development, which is the learning phase. So we have started with understanding existing approaches to architecting our e-commerce application and evolve and shifting to the microservice architectures. In order to understand cloud-native microservices, we need to understand what are monolithic applications and how let us to move from monolithic to microservices. So according to our application requirements, it is good to start requests per second. It is good to start with the monolithic architectures. So we are in learning step of our course flow. For that reason, we will learn monolithic architecture, when to use monolithic architecture, benefits and challenges of monolithic architecture. Let me start with what is monolithic architecture. A monolithic architecture is a traditional approach to software development. Monolithic architecture is an architectural pattern and of designing and developing complete application as a single unit. For example, a traditional application will have a front-end, API, services, load balancer, and database. If you build everything together, and it might seem like going backward in architectural evolution, but in some cases, monolithic architecture is still best option to design your application architecture, especially when you debug business interactions across different modules. But unfortunately, the monolithic architecture has lots of disadvantages. We can say that it becomes too large in of the entire application and so on. So as you can see that we understand monolithic architecture. In this video, we are going and develop the services, it is easier to deploy as only a single jar or WAR file is deployed. So when to use monolithic architecture? The first reason is small team at funding stage. If you are a startup and your team is small, the complexity of the Microsoft, your business requirements to follow the hype and start with means your new product will pivot and evolve a lot over time when you figure out what will be useful to your users. Also, most probably you will end up with fail or stuck at some point with spend. By this way, we can avoid the problems of per second if you don't step. So this is what we are going to do in this course. We will start simple and evolve architecture step by step according to incoming request. As you can see that we have understood that when to use monolithic architectures. In this video, we are going to learn benefits of the monolithic architecture. As you said before, the building applications, any engineering team of monolithic application is easy. The jar or WAR file is deployed. The problem of network latency and security are relatively less in comparison to microservice architecture. So if you are building small application, still monolithic architecture is one of the best architecture that you can apply for your projects. In this video, we are going technology adoption. It is extremely problematic to apply a new technology in a monolithic application because the entire application. In this video, we are going to learn a code or system that is only in one place. Key goal in design and unnecessarily complex on the complexity. By these principles, we will save your time and be able to move forward with project efficiency. So with the following these patterns, we will start to design our e-commerce application architecture that we have learned and we will apply on our project. So let's see which architecture style that we have learned so far. Of course, we have only one architecture style, which is the monolithic architecture. And it is good to add the principles and patterns into our. Now let's design the first iteration of requirements with accommodating function one client and refactor and non-function requirements. In this video, architectures, but this time we need a database to store these functional requirements. So let's add a database into our current design. And a database into our current architecture in order to iteration. You can see that we are separating client and server with different application servers, and we have additional one big ones step by step together and iterate together. In this video, we are going to evaluate our dependencies without layers of isolations. So these are the drawbacks of designing monolithic architecture into our e-commerce application. In this video, we are going to see that we have started to solve any problem and continue to learn new architectures, patterns, and principles with design and iterating our e-commerce application architecture. In this section, we are going to learn layered architecture, which means n-layer. To summarize, we can say that layered architecture is about organizing code for separation of concerns. The main characteristic of layered architecture is the layers of isolation. This means that layers can be modified and the change won't affect the other layers. That means changes are isolated to the specific layer which is modified. So now we can see the components of layered architecture. If you look at the components of a layered architecture for handling databases, for example, basics of n-layered architecture, we should also understand the principles that we will apply on our architecture afterwards. In this video, we are going to learn design principles, which is SOLID principles. SOLID is one of the main principle group to use almost every software projects. SOLID stands for 5 different principles: single responsibility principle, open close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. So SOLID includes 5 different principles all packed into one. So let's unpack these principles one by one. But please consider that we are looking at these principles from architecture perspective. That means we will learn those concepts not only writing code, but also designing software architectures. Each of your components or modules should be responsible only one functionality. Why? Because if you want to change your code, you should first have a good reason. Then you should know where is that single point that reason applies. So we can use these base principles when designing our system and software architecture also. And the second one is open closed principle. When you write your code, the last thing you want to do, go back, you want the legacy code to work, be test to work, and allow new functionality to be built on top of it. So in the same way, when we design the system, it should be able to extend without changing existing architecture. For example, using publish subscribe pattern with message brokers is a good example for that. If you want to notify some other microservices, instead of calling directly the services, we can publish an event and they consume these events from the message broker. By this way, if there will be any microservices need to consume this event, we don't change anything for existing architecture. The only thing to subscribe that event from message broker, and that's all. So our design open for extensions and close for modifications. And another principle is Liskov substitution principle. I'm not going to give deep explanation about that because we are looking at these principles from the system design perspective. So we can say that our systems can be substituted with each other easily. In our case, we can use plugin services that we can shift them easily. For example, if we use RabbitMQ as a message broker, we can shift to Kafka easily with abstracting event bus implementations. And another principle is interface segregation principle. The interface segregation principle offers that no code should be forced to depend on methods that doesn't use. So it splits interfaces that are very large into smaller and more specific ones, so that clients will only have to know about the methods that are interested of the related interfaces. And another principle is dependency inversion principle, also known as a dependency injection. The dependency inversion principle states that high-level modules should not depend on low-level modules. Both should depend on the abstractions. So abstractions shouldn't depend on details. Details should depend upon the abstractions. If you have dependencies in your code, you should allow for them to be injected into your logic. How do you do that? Of course, by allowing them to passing the parameters into your class or other. So this is very useful principle that we can use also system architecture design. We don't want to terms. In order to block these dependencies, we can use message architecting system designs. In this video, we are going to design our e-commerce application with layered architecture and design principle of layered architecture. So after understanding function and now, instead, principles. According to our design toolbox, now let's design our e-commerce application with using the layered architecture. So here you can see the final arc and manage all business logic inside of that. After that, we will separate client application and continue to apply layered architecture with separating logical layers in order to persist data on relational databases. So for now, this is one of the best architecture for us because if this architecture handle our requirements with functional and non-functional requirements, there is no need to design more complex one. In this video, we are going to evaluate and how can we improve this current design. So let's take an action. Here you can see the R layer, horizontal logical layers and separation of concerns. We can say that layers dependent each other. So that means UI layer dependent business layer and business layer dependent data access layer. You can look at the arrow, the image. These are the representing dependency of the layers and this is a wrong design. And this becomes highly coupling layers and highly coupling services, and that is because and becomes hard to maintenance, and it makes complexity of code base, and also it is hard to change and apply new libraries. In this video, we are going to identify any problem for step. We will identify clearly the problem. So if we go further, we will see the problem. Problem is highly coupling dependent layers and the code organization hard to maintain by layer and business layer dependent to data access layer. You can see the arrows in here. This is the dependent layers that makes a problem. We should block these dependencies and organize the code with loosely coupling services. These services and apply to our current design. In this section, we are going to learn clean and testability features in our current architecture. Because in architecture and separation of concerns, we have provide code organization and maintainability into our non-functional requirement. So now with the clean architecture, we will provide flexibility and testability. And now we will learn new architectures, approaches, and pattern and principles related to clean architecture. So let's get started. In this video, we are going to learn what is clean architecture. So that means keep the core business logic and application domain at the center of the solution structure. So we develop core application business logic and domain objects at the core of our architecture and independent with presentation and data access layers. This will provide the flexibility of changing technology and interfaces. Additionally, the core application remains the same and independent of the presentation layer, infrastructure, and databases. So basically, clean architecture divided into two main elements. The first one is the policies, and the other one is the details. That means the policies and the details. The policies are the business rules and procedures, and the details are the implementation code to carry out the policies. In the clean architecture, it is not necessary to choose the database or framework at the beginning of the development. In this video, we are going to see demo for our e-commerce application. As you know that we have designed our architecture with applying clean architecture and the design principle of the dependency rule principle. In this video, we are going to make code review of e-commerce application, which is implemented clean architecture with .NET ecosystem. And you can see the GitHub links on the slide. This is the real world ASP.NET e-commerce web application implemented with clean architecture. I have developed this repository, and if we go to GitHub repository, see that the animation is developed for all. If you can here, you can see the what's including in this repository. This is the e-commerce application, and we have full implementation of e-commerce with adding business rules, authentication, authorization, and ASP.NET built-in dependency injection, and so on. If you scroll down, you can see the prerequisites, installing, and the usage of this repository. But the important part for us is the architecture stuff. You can see that we are implementing the clean architecture. according to clean architecture, at the middle of the architecture, we have a domain model layer, and this layer will be used from the application layer, and the application layer and domain layer has no any dependency from outer layers. So after that, we have an infrastructure layer, which is implemented third-party libraries, anti-framework core, ORM libraries, and we have also web layer, which is the presentation layer, which implemented UI-related components. If you scroll down, you can see the structure of this project. This is implemented clean architecture. We have core structure, and the core layer, we have entities, interface, and value object specifications, basic business rules, including entities into the core section. And after that, we have an application layer. Under the application layer, we have interfaces, services, DTOs, mapper objects, which including the sole business rules under the application layer without any dependency. And after that, we have an infrastructure layer, which including data and repository related logics, which is implemented third-party ORM tools with performing actual database operations under the infrastructure layer and implement the clean architecture. Core layer basically develop domain logic with abstractions. So interfaces drives business requirement with light implementation. The core project is the center of the clean architecture design, and other project dependencies should point towards to it. So this is the core layer. You can see in the core layer we have entities, and here you can see the product entity example code to share in here. If you scroll down, you can see the interfaces into the core layer because there is no dependency specifications. And after that, we have an infrastructure layer. This is the implementation of core interfaces. In this project, we solve the application definition in the infrastructure layer. So you can see that interfaces drives business requirement and implementation in this layer. The application main starting point is in here. This is the ASP.NET Core application, and the application start from this web application startup page. So if you scroll down, you can see the one of the page service interfaces, repository interfaces in here. These are the interfaces, and this is the core layer and state at the center of our architecture. After the core layer, we have application layer, which is the representing our implementation of business logic. You can see that under the application, we have services. For example, if I open the product services, you can see that this is the implementation, but this implementation is using the interfaces, not real objects. So that means we can put in here our business logic with implementing and using abstract classes and interfaces. So this is a good example to store in all business related and go to infrastructure layer. You can see that this is the implementation of our data and third-party related operations. For example, you can see that in this is the UI layer, but at the same time, this is the entry point of our application. When the application starts, this is the ASP.NET Web Application startup page. And under the startup page, you can see the configure method. Under the configure method, we basically inject dependencies when the application startup. For example, iProduct repository injected with the product repository, cart repository injected with the cart repository. And you can see that all dependencies injected when the application startup of the ASP.NET. So by this way, we can provide the clean architecture, and we can use the flexibility and changeability of different infrastructure objects with using this folder structure. In this video, we are going to evaluate clean architecture. In this video, look at the table on the slide. You can see that we have handled scale out with using the load balancers. So now let's learn all these concepts and apply to our architecture. In this video, we are going to learn scalability, learning vertical scaling and horizontal scaling of the application and e-commerce domain non-functional requirements users. So let's talk about the acceptable latency. You can see in here, how can we make
Welcome to this video where we will introduce you to our GitHub repository. GitHub repository for this course is github.com/in28. The GitHub repository contains the presentation which we would be using in this course, as well as 5 different code projects. Also present here is the list of 200 questions that we'll be talking. Also present here is a section on installing the tools. You can follow this playlist to install the different tools that we would need, as also a PDF guide to help you in here. Further below, there are instructions that would help you to set up and welcome back. In this video, we'll address the most important basic questions which are related to Spring. We'll look at the big picture of Spring a little later. We'll talk about Spring modules, Spring projects, and things like that. And also understanding why Spring is popular. We'll handle all those kind of questions a little later once we have a good understanding of Spring. Let's start with the most basic things about Spring, right? When we talk about Spring, we talk about loose coupling. We say Spring enables us to develop loosely coupled applications. We say dependency injection. We talk about Spring inversion of control. And also, we will talk about auto wiring. This is the set of concepts that we will try and get into in this specific video. So the questions which we are going to talk about are things like what is loose coupling? How do you make an application? Now let's start. So this to-do business service here, any application, you have a business and service is done another example. Some sorting them. Coupled sort to quick sort. For this complex algorithm, it will be difficult because you need to actually make the change in here. Thing is, okay, whoever is using the to-do business service can provide an implementation of the to-do data service. Whoever wants to make use of the to-do business service, we are saying, okay, loose coupling is where your code is not tied to the dependency of the complex algorithm. The data layer might need a connection to the database, or it is a dependency. I need to use the constructor. So I'll say new complex algorithm IMPL of new quicksort algorithm. So here I'm creating an instance of the quicksort algorithm. I'm taking it and wiring it and creating another instance of the complex algorithm IMPL. So here I'm creating different beans by myself. However, with Spring, when we say add component, add auto wired and things like that, these things are done automatically by Spring. What does Spring do? Spring sees that there is an at auto wired annotation in here. So as soon as it finds the quicksort algorithm, what it does is it would auto wire it in here. So when it's creating the bean for complex algorithm IMPL, it would auto wire the bean of sort algorithm. This is what is called dependency injection. So what Spring does is it searches for the beans and then finds the appropriate bean and auto wires it in here. This is called dependency injection. Dependency injection is basically the process where Spring framework looks for the beans. It starts searching for the beans, identifies the dependencies, and creates the instances of beans and auto wires them in. So when we use Spring framework, we don't write code like this. All this kind of stuff is done by the Spring framework. This is what is called dependency injection. Concept or other term which is frequently used is inversion of control, right? So what is inversion of control? So in the complex algorithm IMPL, the first implementation of it, which was having tight coupling, had new bubble sort algorithm. So this is tightly coupled. Also, who is taking the responsibility of creating an instance of bubble sort algorithm? It's the complex algorithm IMPL class itself. So the complex algorithm IMPL class is creating an instance of the bubble sort algorithm. So who has the control? The control is with complex dependency of sort algorithm in. The Spring framework would search for the beans and it would inject the dependencies in. So this is what is called inversion of control. So the control which was with the class was taking the control earlier. The complex algorithm IMPL was in control earlier, but now we are shifting the control to the users of the complex algorithm IMPL, or we are shifting the control to the dependency injection framework. This is what is called inversion of control. Actually, if you look at all these concepts, inversion of control, dependency injection, loose coupling, tight coupling, all of them are really related to each other. That's why we thought it is best to have one example and look at it in detail. In relation, it needs to find a bean which would match this dependency in here, and it would need to populate the dependency in. This process is called auto wiring. We'll discuss a lot about auto wiring in the subsequent videos. Here we just wanted to introduce you to the concept of auto wiring. In this quick video, we looked at the different concepts that are really important related to Spring. In the last video, we reviewed the basic concepts of Spring. In this video, we'll look at something called IOC container. We'll talk about different terms like bean factory, application context, and look at how we can create application context with Spring. So let's get started now. What are the important roles of an IOC container? The most important roles of IOC container are to find the beans, to be able to wire the dependencies, find the beans, identify their dependencies, and wire the dependencies in, and also to manage the life cycle of the bean. That is basically creating the instances of the bean and also processing the life cycle events and making sure that the bean is destroyed after complete use. Those are the important ones. Let's take an example. For example, over here, we are actually saying add component on the complex algorithm IMPL, and we are saying add auto-wired on the sort algorithm, and also add component on the quicksort algorithm. So what the IOC container needs to do is it needs to identify that there is add component on these two things. It says, okay, quicksort algorithm and complex algorithm IMPL are the components I would want to manage. These are the beans I need to create. That's number one, identifying what are the important components, identifying the beans. So that's the step one. The second step is to wire dependencies. So I need to also identify the dependencies. So it needs to understand complex algorithm IMPL needs sort algorithm. So I would need to create an instance. I would need to create a bean. I would need to find a bean for the sort algorithm. What it does, the IOC container, it will then go and search for that particular bean. So it first identifies the beans and creates instances of those things which do not have any dependencies. The quicksort algorithm does not have any dependencies, so it creates an instance of it, and then comes here and sees that, okay, this one needs the sort algorithm, so it auto wires it in here. So it will make the sort algorithm available to the complex algorithm IMPL and create a bean of it as well. The important roles of the basic things of an IOC container, it will be able to do that. So it will be able to find the beans, it will be able to do wiring the dependencies, it will be able to manage the lifecycle, it should be able to do. That's it. Nothing more, nothing less. So what is application context? Application context is another IOC container. However, the thing is, this is much more advanced kind of IOC container. It is almost something you can call as Bean Factory plus plus. So whatever Bean Factory has, it provides all those features. And in addition, what it does is provide things like your AOP, like aspect oriented programming is one of the important things we would discuss later. So it provides all the features that we would discuss in the aspect oriented programming part, and it provides internationalization capabilities as well. So things like message sources and things like that we'll talk about guided by application context. Bean Factory provides the basic features. Application context is Bean Factory plus plus, and it provides all the features like AOP features, internationalization, web application context features on top of Bean Factory. We looked at the important roles of an IOC container. We looked at Bean Factory application context, and we compared Bean Factory with application context as well. The most important thing you need to remember is in most of the circumstances, Spring recommends you to use an application context. So in most of your applications, you'll always go with application context because you need features like internationalization. You need to be able to create a web application context and things like that. However, you would want to go with the Bean Factory only when you are in severe memory constraints. You don't want to use a lot of memory in your application. In those kind of situations, you would go with some use an application context. Next, we would want to discuss how to create an application context with Spring. Creating an application context with Spring is very, very simple. You can actually define the context in two ways. Either you can define it using an XML, or you can define it using an annotation called add configuration. So inside Spring, there is an annotation called add configuration, which you can use to define an application context configuration as well. So the options which are available, we'll look at them in the XML. So it looks for these XMLs. Where does it look for? In the class path. Class path XML application context is one of the ways of creating an application context using XML configuration. And we can create an application context for that using an annotation config application context. You can also create an application context in your unit test, right? So in your unit test, you would want to launch an application context quickly. In those kind of situations, we can use something called a Spring JUnit configuration, or you're using a Java configuration. You'll be able to easily use them in your typical Java code as well as in your unit tests. In this video, we quickly reviewed the concepts of to create an. Welcome back. In this video, we'll focus on the questions which are related to component scan. So we'll talk about questions like, how does Spring know where to search for components or beans? What is a component scan? And how can you define component scans in XML and Java configurations? As well as, how does component scan work with Spring Boot? Actually, component scan is one of the most important features which is present in Spring. In our applications, we define all the beans that we would want Spring to create, right? So I would say complex algorithm IMPL and put an add component on it. Quicksort algorithm and put an add component on it to say this is something which Spring needs to manage. However, there might be multiple packages and multiple places where these add components might be defined. If Spring tries to search every package which is there for components, then that will be a big performance impact. We need to help Spring find where our components are. Where did we define our beans? We would need to help Spring identify that. What we'll do is we'll specify, okay, Spring, go and look in business service package. Go and look in data service stub package. These are the packages where beans are defined. And that is what is called a component scan. Component scan is basically a search Spring does for components. input for that search is the packages. So you would say, I am looking for package A, B, C, D, E, F, and Spring would go there and search for the components. So actually, Spring does not know where to search for components or beans. You need to tell it. So you need to tell, okay, this is the package where I have my components in. And what is component scan? Component scan is basically the process where Spring looks for these beans. And how do you define a component scan in XML and Java configurations? This is how you do that in a Java configuration. So in a Java configuration, you can have an annotation called add component scan. So you can say add component scan and specify all the packages that you would want to scan for. Here I'm specifying two packages, business service and data service. You can specify com in 28 minutes.spring and scan the entire thing as well. So you need to decide whether you want to specific or you would want to be generic with your component scan. The other way to define your component scan is in an XML. Over here, we're actually using something called context component scan. And we are specifying one package in here. So we are saying, I would want to search com in 28 minutes example for all. Welcome back. In this video, we would want to focus on what's the difference between add controller, add component, add repository, add service, and these kind of annotations in Spring. We already used add component and add auto add annotations, right? So what does add component signify? It signifies the fact that something is a bean that needs to be managed by Spring. If I put add component on something, then I'm telling Spring, okay, Spring, you are in control of this bean. You create this bean, you fire the dependencies in, you take care of destroying the bean at a later point in time as well. So that's what add component signifies, right? Add auto add is all about finding the matching bean. On a dependency, you would add to auto-wire, and what do you expect Spring to do? You would expect Spring to find a matching dependency and auto-wire it in. These are things which we have been discussing a lot in previous videos as well. Now, let's come into the most important part of this video. That's the difference between add component, add repository, add service, and add controller. At a high level, when we look at add component is the most generic abstraction. What are add repository, add service, and add controller? Let's look at it in detail. When we talk about web applications, we would talk about multiple layers, right? You have a web layer, you have a business layer, and a data layer. You can use add component on any of the components in any of these layers. So it's very generic. However, we used in the web layer. Add controller signifies something which is using the MVC pattern, model view controller pattern. That's in the web layer. Add repository, on the other hand, specifies something on the data layer. You would use add repository typically on things like a DAO, data access object. So these are the things which are really related to getting the data from your database, whether it's a relational database, whether it's a big data store, it doesn't really matter. So whichever data store you are talking to, you would use add repository on top of it. The last one, add service, is typically used in the business layer. In your business logic, the most important functionality that you would want to provide is transaction management. All your facade objects which are present in the business layer, you would use add service. There is also a little bit of meaning which is attached to these annotations by Spring Framework as well. So when you tag any component with add repository, Spring would automatically add the exception translation for JDBC exceptions. So whenever a JDBC exception happens, then it needs to be translated into the specific Spring exception. So if you put add repository on top of any component, then that happens automatically. And we look at add controller a lot more when we talk about the MVC. What does it signify? What is the output? What's the input to an add controller and things like that. In summary, add component is the most generic one, and add repository, add service, add controller are supposed to be used in their specific layers. Kind of provides an additional way you can classify your components and identify them if you want to add any specific functionality for that specific layer. So if you want to, let's say, log all the inputs and outputs that are going from your data access methods, then you can look at add repository as a way to identify your beans and weave your AOP around them. In this video, we looked at add component, add auto-wire, and we also looked at the differences between add controller, add component, add repository, and add service annotations. Until the next video, bye-bye. Welcome back. In this video, we'll focus on the scope of the beans. So we'll look at things like what is the default scope of a bean? Are Spring Beans thread safe? What are the other scopes which are available? And also we'll look at how Spring Singleton Bean is different from the Gang of 4 Singleton pattern. Let's start with the different scopes which are present in Spring. So when I create a bean, you can specify any of these scopes. I can say it's a singleton, it's a prototype, a request, or a session. There is another scope called global session, which is used in the context of a portlet, where you would want to share a context among different portlets, but portlets are no longer used, and I don't really want to confuse you with the global session. Excluding the global session, there are actually 4: singleton, prototype, request, and session. So singleton is something, it's basically one instance per Spring context. When you create an application context, there's only one instance of that particular bean. That's singleton. Prototype is whenever there's a request for that bean, you create a new instance for it. So if in a single application context you have 100 requests to that bean, then you create 100 different instances. So it's basically a new bean that's being created whenever it's requested for. The next two scopes, request and session, are both applicable only in web application contexts. So these are only applicable to those contexts which are web aware. These are more in terms of web applications. So in the web applications, you have something called a request and a session, right? When a user performs an action on the browser, let's say he clicks a link. So it sends a GET request to the Spring application. And also, you'd want to be able to track the details of the user across multiple requests. So what we do is we create a session for that specific user. So if you would want a new bean for every request, so whenever user clicks a link, whenever he sees a page, whenever he performs an action on that page, you'd want a new bean to be created. Then that means you would want a bean created per HTTP request. And in that kind of situation, you would use something called a request scope. The other kind of beans where you'd want to store something like a user specific information. Once you get that user information, you can actually store it for the entire session of the user. In those kind of situations, you would use a scope called session. These session beans are one bean per HTTP session. So these are the four scopes which are available. The most important thing is by default, all the Spring beans are singleton. So by default, what is the default scope in Spring? It's singleton. If you don't define a scope, then you get a scope of singleton. So there will only be one instance of that bean per a Spring application context. Are Spring beans thread safe? They're not thread safe by default because Spring beans are singleton by default. That means you only have one instance of that bean for all the threads which are under execution. So if you have 100 threads which are executing at the same time, for all of them, there is only one bean which is available. So you cannot have user specific information, or you cannot have some information which is different for different threads in a bean which is of scope prototype. In summary, Spring beans are not really thread safe. We looked at the other scopes which are available, right? Prototype, request, and session. This is in addition to obviously the default scope, which is singleton. The last question is, how is Spring singleton bean different from Gang of Four singleton pattern? Singleton is one of the famous design patterns, right? So Gang of Four provided a list of design patterns, among which singleton is one among them. In the Gang of Four singleton pattern, it's actually one instance per class loader. Singleton is a class which can have only one instance per a specific class loader. Typically, we use singletons to represent things like, let's say, a list of states in a country, list of countries. These are not going to change. So I just create a singleton object for this and I'll have them. Typically, when we say singleton, it means one instance per class loader. However, with Spring, the Spring singleton is one instance per container, one instance per application context. That's the most important difference. If you have multiple application contexts inside the same JVM, then you would have multiple instances of that particular bean. So Spring singleton is actually one instance per application context or one instance per container. That's the most important difference between Spring singleton and Gang of Four singleton. In this video, we discussed the various important questions related to scope of a bean. Until the next video, bye-bye. In this video, we'll discuss about different types of dependency injections that are present in Spring. In Spring, by default, we support two types of dependency injections, setter injection and constructor injection. We look at both of them and also how do you choose between setter and constructor injections. Let's look at it right now. So what are the two different types of injections? We already said setter injection and constructor injection. What is setter injection? You can look at this to-do business service. We talked about to-do business service, and data service is actually one of the dependencies. Here, if you look at this example, we are creating a setter. So we are saying, okay, set data service. So this is a setter to set the to-do data service. And we are putting an at AutoWired on top of it. So what we are telling Spring is use this set method to wire the dependency in. Use this set data service method to wire the data service in. This is what is called setter injection. So setter injection is basically injection that happens through a setter that we provide. We put at AutoWired on top of it, tell Spring, okay, use this setup. Now, what is constructor injection? Constructor injection is the same thing happening through a constructor. So what we did is we created a to business service constructor, which is accepting an argument to do data service. I've also put an at AutoWired on top of this. So what does Spring do? Spring would use the constructor to do the wiring. This is called constructor injection. Spring would call this method. Spring would call the constructor method. So this is called constructor injection. Setter injection, we use the setter. There is one more important type when I don't define a setter. So let's say for a specific dependency, I don't have a setter as well as a constructor. I put at AutoWired on the bean directly. and there is no setter and constructor. In these kind of situations, Spring would use reflection to wire this specific thing. However, for all practical purposes, this also fits into the category of setter injection. When we talk about setter injection, it's actually putting an AutoWire on top of your setter or putting an AutoWire on top of the data service, on top of the instance directly or on top of the dependency directly. And constructor injection is all about putting an AutoWire on top of your constructor, using the constructor for injecting the dependencies in. Comparing constructor versus setter injection. When you talk about dependencies, there are basically two types of dependencies. One is called mandatory dependencies and the other one are optional dependencies. Over here, data service is a mandatory dependency because this business service needs this data to be there. So only when this data service is there, it will be able to take care of its work. There might be things like internationalization and things like that. If you have dependencies like that, those are not really mandatory. So if you don't internationalize something, probably you can use the defaults and show them to the user. So those are not mandatory. Those are what are called optional dependencies. Typically, Spring Framework advocates, I mean, this is basically the advice which is present in the Spring documentation, which I have referred in here. The Spring team actually advocates using Spring constructor injection. So they say use constructor injection always. For me, the most important thing is use constructor injection for mandatory dependencies and setter injection for optional dependencies. If you have optional dependencies, whether they're there or not, it doesn't really matter sometimes. So you can use setter injection for them. You can use constructor injection for mandatory dependencies. The most important advantage of a constructor injection is the fact that the entire bean is created at one instance. So you're creating basically a immutable bean. You're not changing the bean at multiple times. However, when you use setter injection, you'd first create a bean using the default constructor, then call set on this dependency, call set on another dependency. So you're changing the state of the bean. That's one of the important reasons why constructor injection is preferred, because it helps us create immutable bean. And immutability is something which you'd want to promote in your application. The second important thing why constructor injection is preferred is because if you have constructor defining all the dependencies, then what would happen is class is 15 dependencies, then you would have 15 arguments in your constructor. So you'll have all the arguments specified in here and the constructor becomes really complex. That's a good signal to you to start refactoring. So this can actually work out as a code smell. So if you are having too many dependencies and you're using constructor injection, you can directly identify that there is a problem with your code. You are having too many dependencies. That means you need to refactor it further. However, if you're doing setter injection, then all that you need to do is something like this, right? So at AutoWired and do this, and you just put 15 things like that. It is not so obvious. That's the reason why constructor injection is recommended by Spring team. A, it promotes immutability. The second thing is it clearly highlights the facts that your code is having a lot of dependencies. In this video, we looked at the different types of different dependency injection, setter injection and constructor injection, and we looked at what are the important differences between them and how do you choose between them. So as far as possible, try and go for constructor injection. That's basically the advice. In this video, we would want to look at the different options which are present for Spring application context, XML and Java, and how do you choose between them. In a way, we have actually discussed this in one of the earlier videos as well. So this might be a little bit of repetition, but the important thing we would also want to discuss is how do you choose between XML and Java configurations. Also, we think this is an important concept, so let's discuss it one more time. Let's look at the XML way of configuring your application context, right? So as we looked at earlier, so you define a XML context with all your beans. So in here, you'll define all your beans. Between your beans and beans, you define all the beans that you would want to define. And you can launch it using class path XML application context. So in your main method, you can do this. And this would try and find this business application context.xml and other configuration.xml in the entire class path of your Java application. The Java way of creating a Spring context is also very simple. You just need to put add a configuration on your configuration bean. You can use add beans to define all the configuration which is present in here. And you can launch it up using annotation config application context. All that you need to do is send the class name dot class. So these are the two ways, right? Java and XML. Which one do you prefer? Actually, with things like auto wiring and things like add component, add auto wired, and the prominence of the use of auto annotations, the amount of configuration which we actually put either in our XML or in our Java is very minimal. Right? So when I talk about a big Spring application, probably I'm talking about 150 lines of XML configuration or something like 100 lines of Java configuration. What are we talking about is quite a minimal thing. So it's not really as important decision to make as it was before the use of annotations. Before the use of annotations, we had to write big Spring application context XML files. So you have to define the beans define the dependencies, fire them in. All that work you had to do that in the XML. But with at AutoWired and things like that, you don't really need to do that. So the amount of configuration that we do in our XML or the Java configurations is very, very less. Actually, there is very little to choose. So whether you'd want to use a Java configuration or an XML configuration, you're good to go. You can actually use either of them. I don't really have a preference among them. But with Spring Boot and Spring Boot having this awesome annotation at Spring Boot application and it automatically launching the context up, as soon as I put at configuration on something, it would be picked up as Spring configuration. If I have to use XML with Spring Boot, then I have to do a little bit more configuration. So I prefer now the Java configuration, especially in Spring Boot applications, because I don't really need to do any configuration at all. All that I need to do is put at configuration on a bean where there is Spring configuration, then it's picked up automatically. If you're new to Spring Boot and this was not clear to you, that's not a problem at all. We'll discuss that a little more when we talk about Spring Boot in one of our subsequent sections. For now, the important thing is there is hardly anything to choose between the XML and Java configuration, except when it comes to Spring Boot applications where Java configurations are automatically picked up, and I have a preference for using Java configuration. Until the next step, bye-bye. Welcome back. In the previous video, we talked a lot about auto wiring. How does Spring really do auto wiring? How does it know what is the matching bean for a specific dependency? Let's discuss that more in this specific video. There are three different ways Spring does auto wiring. One is by type, the other one is by name, and the last one is by constructor. This is actually very similar to by type because it actually finds the matching constructor by the type. Let's start looking at each of them. The most basic way Spring tries to find the dependencies is by type. By type, we mean a class or an interface. So over here, sort algorithm is the interface, and quicksort implements sort algorithm. And when Spring sees that complex algorithm IMPL needs sort algorithm, it searches for any implementations of this interface. So if the sort algorithm was a class, it will look at the class type. So it will search for classes which are of that specific type. But because this is an interface, what Spring searches for is implementations of that interface. Quicksort algorithm is one of the implementations of that interface. When Spring sees that quicksort algorithm can be put in here, it would auto-wire it in here. This is auto-wiring by type. The other kind of auto-wiring is by name. In this example, when you look at it, sort algorithm interface is implemented by two algorithms, quicksort algorithm and bubble sort algorithm also. Now Spring finds two components matching by type for this one. So it finds two implementations of the sort algorithm interface. In these kind of situations, Spring would go by the name as well. So here, quicksort algorithm. So it matches with this quicksort algorithm in here, except for the first queue. So Spring understands camel case. So it says quicksort algorithm matches with this in here. So let's do auto wiring by name. Here, auto wiring happens by name. Earlier, it was by type. This is by name. The other type of auto wiring is by finding a constructor. So Spring sees that, okay, this to-do business service constructor has to-do service as the dependency. So it will try and find a dependency of this type and use the constructor for doing the auto wiring. The different types of auto wiring algorithms that Spring uses are by type, by that we mean by class or interface, by name, by matching the name of the dependency instance with the bean class name, and also by finding an appropriate constructor with the same type. It's also similar to by type. Until the next video, bye-bye. Welcome back. In this video, let's discuss about how you debug problems with Spring Framework. How do you solve problems such as no unique bean definition exception, no such bean definition exception, and also to understand what are the options you have with at primary and at qualifier. Let's get started now. Look at this example. I have a complex algorithm IMPL which is declared as at component and sort algorithm at auto wired on here. But there is no at component on both quicksort and bubble sort as well. Quicksort algorithm and bubble sort algorithm do not have at component on them. When Spring searches for some bean which matches this dependency, it will not be able to find anything because there is no at component on these two beans. These are not Spring beans anymore because they don't have at component on them. So in these kind of scenarios, what Spring does, it throws a no such bean definition exception. So it says, I want to find an implementation of the sort algorithm, but I'm not able to find it. It says unsatisfied dependency through field sort algorithm. No qualifying bean of this type is available. It says expected at least one bean which qualifies at auto wire candidate. So it says, I'm trying to find something to autowire in here, but there is nothing found. Actually, in some situations, you might really have add component on here. So there is add component on quicksort algorithm, but still Spring might not be able to find it if you have not defined the component scan well. Let's say this is in package X and this is in package Y, and you are scanning only package X for components. What would happen? Spring will not be able to find quicksort algorithm because it's in package Y, which is a different package from X. Whenever you find yourself handling something like no matching components or no such bean definition exception, or you see something of this kind, no qualifying bean of this type available, typically the problem would be that either you did not put add component on something, either you did not put add component or one of those related annotations. You should have either add component, add repository, add service, or add controller. One of those annotations should be on your Spring beans. And the second problem might be with your component scan definition. If a bean is not part of the component scan, if this is in a package Y and Y is not being scanned for components, then Spring will not be able to find these beans. So whenever you find this exception, those are the two prominent reasons. The reasons are A, either the add component or one of those related annotations is missing, or add component scan is not really defined properly. Other end of the problem is two matching components, that is more than one matching component. So the sort algorithm, now there are two implementations of that, quick sort algorithm and bubble sort algorithm. What should Spring do in that case? Here you see that there is autowired and there are two components. Let's say all these classes are in the component scan. So they are all being scanned. So Spring finds two components for the same thing. And it tries to match by name, sort algorithm. It sees none of the beans also match by name. So what does Spring do? It throws an exception. It says field sort algorithm in this requires a single bean, but actually two were found. It says bubble sort algorithm and quick sort algorithm. I'm searching for one, but actually I'm finding two. In this kind of situation, Spring throws a no unique bean definition exception. So it says, I'm not able to find a unique bean definition. I'm finding two, more than one bean definitions, and I've not been able to match one correctly. So how do you solve these kind of problems? One of the options which we looked at is by naming it properly. So here, if I want to use quicksort algorithm, I'll call the instance name quicksort algorithm or bubble sort algorithm. That's using autowiring by name. The other options which are present are to use something called a primary. So you can say bubble sort is my primary algorithm. So if there are multiple instances of sort algorithm in the component scan, then bubble sort is the primary one. So now what Spring does, it will start using bubble sort algorithm to execute the complex algorithm IMPL. The other option is by using a qualifier. On the dependency, in addition to the add autowired, we put something called add qualifier and give it a name. So I'm saying the qualifier is main algorithm. So whichever bean has this qualifier on it, the bubble sort algorithm now has main algorithm qualifier on it. So whichever bean has that qualifier on it, it will be autowired in. So there are basically three options when you have multiple dependencies on the class path or in the component scan actually. So if you have more than one dependency on the component scan path, then you can either use the name to differentiate them. So instead of calling it sort algorithm, you'd call it quick sort or the bubble sort algorithm so that the matching can happen by name. If you can't do it by name, you have the option to do it by putting an add primary to indicate one of your algorithms is the primary algorithm for sort algorithm. That becomes the most important one. And the other option is to use a qualifier just by putting a qualifier with a specific name and also using that qualifier on your bean definition. In this video, we looked at some of the problems you might be facing with Spring Framework with respect to component scan and finding the beans and wiring them in. And we talked about using add primary and add qualifier annotations to solve those problems. Until the next video, bye-bye. Welcome back. In this video, we would be talking about CDI, context and dependency injection. We'll understand what is context and dependency injection, and also does Spring support context and dependency injection, and also which is the recommended approach to use CDI or Spring annotations. So what is context and dependency injection? What is CDI? CDI is basically a dependency injection standard for Java EE. Just like JPA is a standard for defining your Java persistence annotation. So JPA defines few annotations and a few interfaces which you can use to implement your object relational mapping. Similar to that, CDI defines API for doing your dependency injection. Spring is one of the most popular dependency injection frameworks. And Java EE dependency injection standard, JSR 330, creates this new thing called CDI, context dependency injection, which is kind of the API for how Spring should work. However, it uses different annotations compared to what Spring uses. For example, whatever we call at autowired in Spring is actually at inject in CDI. Whatever we call at component is at named in CDI. And at singleton is what is used to define a scope of singleton. So in terms of the meaning, it's almost the same. So when I say at inject in CDI, it means I would want to auto wire something in here. When I say at named, it means I'm defining, I would want the context dependency injection framework to manage this bean. This is like at component. And when I say something is at singleton, then it means there will be only one instance of that specific thing per application context or per instance of the IOC container. Actually, when you look at Spring, Spring supports most of the stuff that CDI provides. So instead of at autowired, you can easily use at inject, and instead of at component, you can use at named. And to define a scope of singleton, it's actually default. But if you really want to go ahead and do that, you can say at singleton as well. Spring supports most of the CDI annotations. What is CDI? CDI is just a simple API for doing dependency injection. It kind of tries to standardize dependency injection. Does Spring support CDI? Yes. Spring does support most of the annotations which are present in CDI. And which one do you recommend to use, CDI or Spring annotations? Actually, that's a really, really tough question. If you look at CDI, it's just standard. So it's a Java EE standard. And that's very cool, right? You always want to go by the standards. So from that perspective, you might want to take and adapt CDI annotations in your applications. However, what I've seen in my experience of last 15 years is Spring always stays one step ahead. Whenever there's a new feature, the highest probability is that you'd find it in Spring first, and then it comes into Java EE. The choice is between a standard versus an implementation which stays a little bit ahead. I don't think there is one very clear choice in here. I think you would not go wrong with either of these choices. In this video, we looked at CDI, and also we talked about how Spring supports CDI, and also how do you make the choice between CDI and Spring. Until the next video, bye-bye. In this video, let's focus on the major features in different versions of Spring. So we'll look at from the first few versions of Spring, what are the features in each of those versions, and also what are the new features in Spring 4 and Spring 5. Let's get started now. So if you look at version of Spring Framework where there was a very big change, for me, Spring 2.5 was the first one. Because before 2.5, there was no support for annotations. There was no at autowired, there was no at component, or there was no at controller or any of that kind of stuff. So there were no annotations which were present in the earlier versions of Spring, and all the wiring had to be done by hand. So if I have to define a bean in the XML, I have to define that bean, I have to define the dependencies and wire them in. And it was really a tough world to program in. You need to write your Java code, and parallel to that, you would have a XML, which is 1,000 lines big. And that was very difficult to maintain. And for me, Spring 2.5 was a major Spring revision because it brought in annotations, and it brought in the support for at component, at autowired, and things like that. Spring 3.0 was the first version of Spring which made use of the Java 5 improvements in the language. Java 5 brought in a lot of improvements, right? Along with annotations, for loops, and things like that. So Spring 3 made use of those annotations. Spring 4 was the first version of Spring to support Java 8. Java 5 and Java 8 are the major releases for Java, right? So Java 5 brought in annotation support, and Java 8 brought in things like functional programming and other stuff. So those are two important releases of Java, and Spring 3 was the first one to support Java 5. I mean, first one to use Java 5 in its implementation, and Spring 4 was the first one to support Java 8 features. We had to wait until Spring 5 before Java 8 features were used in the Spring framework itself, because it had to still support Java SE6. So if Spring framework was using Java 8 features, then it will not be able to support Java 6, Java 7, and other stuff. So Spring itself was not really using the Java 8 features, but applications which were built in Spring could have used the Java 8 features. So with Spring 4.0, you could develop applications which used Java 8. The other major change in Spring 4 was the support for at-rest controller. This was the type when REST services started picking up very well, and world started moving towards RESTful services, and now we are moving towards microservices. So Spring 4 was the first one to introduce the at-rest controller to support implementation of RESTful services, and also support for JCache. The Java API for caching was introduced as part of 4.1. Spring 5 is the first version of Spring where there is a functional web framework. So you can use the concepts of functional programming to even develop your web application controllers. One of the important things that Java is working on is this thing called Jigsaw. It's related to Java modularity. The size of the Java installation has went up almost 10 times since Java 1 to Java 8. So if I have to install a JVM for Java 8, I would need more than 150 MB. And that's a lot of memory when it comes to IoT devices. And for Java to support such kind of devices, we should be able to live with much less memory. Today, the way Java is if I want to develop any Java application, I would need the entire JVM to be present. I cannot say I want this part of JVM only. And that's what Java modularity with Jigsaw aims to bring in. And Spring 5 aims to support the Jigsaw approach to Java modularity. Spring 5 also has good support for reactive programming. In reactive programming, a lot of emphasis is on building applications around events. So whenever something happens, we generate an event and the rest of the application reacts to that. Spring 5 through Spring Webflux brings in support for reactive programming. Kotlin is one of the evolving languages as far as the JVM languages are concerned. And with Kotlin, you can write Java applications in much lesser number of lines. And Spring 5 has good support for Kotlin. In this video, we discuss at high level what are the different important features in different versions of Spring and what were the new features in Spring 5. Until the next video, bye-bye. In Spring, there are a wide range of modules which are present in the Spring framework. When we talk about Java applications, we build applications with multiple layers. Each layer has its own concern that it's trying to implement, right? So you have a web layer whose concern is to get the data from the browser or get the, like if it's a web service, then provide the external interface so that it does all the translations from your JSON format to your beans or from your XML format to your beans or things like that. So that's kind of the role of a web framework, to provide the view, to provide the external interface. The business layer is concerned with the logic. So it's concerned with what is the business logic of the application. How do I make sure that the business logic is written well? How do I make sure that transactions are properly implemented and things like that? Those are the concerns of your business layer. The data layer is concerned with how do I talk to a database? How do I talk to an external system? How do I talk to a big data store? Each of these layers have different concerns, and Spring Framework has different modules for each of these layers. And also, there are things called cross-cutting concerns, which are concerns of multiple layers. And Spring also has modules to support that. Let's start with the core container. The core container is the crux of the Spring framework. The core features of Spring, as we discussed earlier, are dependency injection, auto wiring, managing the beans. So this is where all those features are: beans, core, and context. Context here actually means application context. And also, Spring has a SPXPL, that's Spring Expression Language, to support the definition of beans and things like that. So this is the core container. This is where all your bean factory, all your application context, and all that features come in. Next, we will talk about the data layer. Spring has its own JDBC framework called Spring JDBC. Spring JDBC makes it easy to talk to a relational database. With typical JDBC, when you talk to a database, you need to do 100 different things. And with Spring JDBC, you don't need to do any of those. We'll look at Spring JDBC in detail a little later. So if you have a JDBC application, if it's, let's say, taking 1,000 lines, you'd see that with Spring JDBC, you can do the same thing in less than 200, 250 lines. Spring has good integration with the ORM frameworks, object relational mapping frameworks. Spring connects well with Hibernate, which is one of the popular ORM implementations. Spring also has good OXM module, object XML mapping module. So it has good integration with other object XML mapping frameworks, for example, JAX-B. And Spring also has good integration with JMS. Spring JMS provides a JMS implementation. You'd be able to talk to other applications over the queues using JMS, using Spring JMS. Spring has built-in support for transactions as well. You'd be able to use Spring transactions and manage transactions for your JPA application or your Hibernate-based application or your JDBC-based application, any of them. Moving on to the web layer, Spring has really good support for servlets and portlets. And Spring has a web MVC framework of its own. It's called Spring MVC. Using Spring MVC, you can develop web applications very easily. And also, Spring has good support for REST. So the Spring MVC framework can also be used to develop RESTful applications. Spring also has a module to support WebSocket programming. So we looked at data layer, we looked at web layer, and there are things which are related to multiple layers. These are called cross-cutting concerns. Typically, cross-cutting concerns are things like logging, exception handling, and things like that. These are concerns of all the layers which are present in your application. For example, security as well. AOP is a very good way to implement your cross-cutting concerns, aspect-oriented programming. Spring provides a basic aspect-oriented programming module of its own, and also Spring has good support for AOP frameworks like Aspect-J. We'll look at these two aspects a little later as well. The last, but not the least important of the modules is Spring Test. One of the most important reasons why Spring is very popular is dependency injection. And with dependency injection, we'd be able to write tests very easily. We'll be able to write unit tests, integration tests very easily with Spring. And Spring Test helps you to write unit tests and integration tests. In this video, we took a quick look at all these Spring modules. The most important thing is the fact that all these Spring modules share the same version as the Spring framework. So when I say there is a new release of Spring, Spring 5, then it means there would be a new release for all these modules with the version 5. That's the most important difference between modules and projects. When I talk about modules, they'll have the same release version as the base Spring framework. In the next video, we'll look at Spring projects. These are things which are related to Spring, but they don't share the same version. So probably when I say Spring version 5, and Spring Boot might be using a version 2. So they will have different versions compared to Spring and Spring modules. We'll look at that in detail in the next video. Until then, bye-bye. In the last step, we looked at different Spring modules. All the Spring modules have the same release version as the Spring framework. So they are almost like they're part of the Spring framework. There are other things Spring does other than the Spring framework and its modules. These are called Spring projects. These Spring projects provide solutions for different problems faced by enterprise applications. In this video, let's look at a few of them. Let's start with Spring Boot. Spring Boot is one of the most popular frameworks to develop microservices today. Within a few years, Spring Boot has become the most popular framework used for developing microservices. Spring Boot makes it very, very easy to develop applications quickly. With features like startup projects, auto configuration, actuator, Spring Boot makes developing applications, especially microservices, a cakewalk. The other important Spring project is Spring Cloud. We know that the world is moving towards the cloud, right? Everybody wants to deploy their applications in the cloud. And therefore, it's not sufficient if we develop good applications. We have to develop cloud native applications. We would want to be able to dynamically configure applications. We would be able to dynamically connect them. We would want to be able to dynamically deploy applications. Cloud native applications need a lot of different features. So if you have a microservice which is developed using Spring Boot, you can use Spring Cloud to cloud enable the microservice. Spring Data provides a consistent data access. If I go a few years back, there was only one kind of databases that we typically connect to. We would connect to a proper SQL database. Today, there are abundant of NoSQL databases. We have a mix of data sources. So we have we have a wide variety of NoSQL databases. We have SQL databases as well. How do you ensure that the way I'm accessing data from all this stuff is remaining consistent? That's what the Spring Data aims to solve. Spring Integration, on the other hand, addresses problems with application integration. There is something called Enterprise Application Integration Patterns. It's a very famous book. Spring Integration implements the patterns which are recommended in there. Spring Integration helps us in connecting enterprise applications very, very easily. Not all processing is done online. Some of the processing is also done in batch applications. Batch applications have their own requirements. Like, for example, I would want to be able to restart a batch job from where it failed. Or I would want to be able to track down exactly what's happening in a batch in much, much more minute detail. Spring Batch provides those kinds of features. It enables developing batch applications very easily. Security is one of the important parts of developing applications. You'd want your applications to be secure. Whether you are developing a web application, whether you are developing a REST service, or anything that you develop, you'd want to protect it. So Spring Security provides solutions for securing your applications, whether it's a web application, whether it's a REST service. Spring has support for multiple security. Spring Security has support for multiple security options like basic authentication, OAuth authentication, OAuth 2, for example. Spring HATOS enables you to develop HATOS compatible services. In REST, it's not sufficient if you just return the data. You'd also want to return the related links that would help the consumer to understand where to go from here. Spring HATOS would help you to do that very easily. What we are looking at are 7 of the Spring projects. They are just touching the tip of the iceberg. There are a lot of other Spring projects like Spring Web Services, Spring Session, Spring Social, Spring Mobile, and Spring Android, which are solving problems in various different spaces. Spring has not really restricted itself to just the Spring framework and got involved in a lot of wide variety of projects. All the stuff you are learning as part of this Spring course would also be useful when you are developing on any of these Spring projects. Until the next step, bye-bye. Welcome to this video where we will be talking about a couple of questions. Let's start with the first question. What is the simplest way of ensuring that we are using single version of all Spring related dependencies? One of the problems you would have typically in your application is you don't want to specify the same Spring version multiple times, right? So if you have Spring Core, Spring Beans, Spring AOP, and different modules from Spring you're making use of, you want to make the same version. You want to use the same version of Spring for all of the Spring modules. The easiest way of ensuring to do that is by using something called a bill of materials dependency. So this bill of materials Spring dependency declares the dependency versions for all the Spring modules. Once you import this in your dependency management, so in the POM, there is a section called dependency management. So in the dependency management section, if we add a dependency on the Spring Framework BOM for 5.0.0 release, for example, then in your dependencies, you don't need to specify the version at all. The version for the Spring context will be picked up from the Spring Framework BOM. So here, the release version of Spring Framework BOM is 5.0.0 release. So the version of Spring context which will be used will also be 5.0.0 release. And same is the case for all other Spring dependencies as well. For example, you're talking about Spring-Web, which is the dependency to develop your web applications with Spring MVC. Or if you're talking about Spring Core or Spring Beans, you don't need to specify the version from now on. So all that you need to do is include dependency management, include the BOM in the dependency management, and that's it. You don't need to specify a version for any of your Spring dependencies henceforth. The next question we would be talking about is what are some of the design patterns which are used in Spring Framework? There are quite a few design patterns which are used in Spring Framework, right? So when we talk about Spring MVC, which we'll be talking about a little later, you'd see that there is something called dispatcher servlet. Any request from the browser would first go to the dispatcher servlet, and only then will it go to any of the other controllers. This pattern is called front controller pattern. So all requests from the browser would first go to the dispatcher servlet. Dispatcher servlet would identify the right controller and distribute the thing to the controllers. So that's one good example, front controller pattern, dispatcher servlet. The other important thing which Spring does is managing the beans and the dependency injection. So these are two other patterns which Spring uses. So whenever we develop a Spring application, we are using a prototype. So we are creating one instance of the bean. That's the prototype pattern. And also we are using the dependency injection pattern because all that we would be doing is doing at component and at AutoWired. The bean factory and the application context are implementation of the factory patterns because those are the factories which manage the beans. One another design pattern which is frequently used in Spring is template method. If you look at abstract controller, or if you look at JDBC template or JMS template, all these are examples of template method patterns. If you look at the abstract controller, it's an abstract class. It defines an abstract method called handle request internal. And what it does is it defines all the logic around the handle request internal in this handle request method. So it kind of creates a wrapper around the handle request internal. I can go ahead and override the handle request internal and implement a version of it myself, but the basic wrapper around it is provided by abstract controller. This is basically what is called a template method pattern. The next question we would want to talk about is what are some of the important Spring annotations you have used? Actually, during the last few videos, we discussed about quite a few annotations, so you can actually code any of them. So at component, at service, at repository, controller, at AutoWired, at primary, at qualifier, and at configuration. At configuration, if you remember, it was used to define a Spring context configuration. So if you want to define the configuration for a Spring context or a Spring application context, we used at configuration. We can define beans in there. In this video, we took a quick look at some of the basic questions related to Spring. How do we ensure that one version of Spring dependencies? BOM. Some of the design patterns used in Spring Framework. We talked about prototype, factory, dependency injection, front controller, and template method. And we looked at a few of these important Spring annotations. Until the next video, bye-bye. Before we end this section on Spring, we would want to discuss a high-level question about Spring Framework in this video. You typically be asked questions like, what do you think about Spring Framework? Why is Spring popular? Or can you give a big picture overview of the Spring Framework? How do you go about answering that? That's basically what we would discuss in this video. When I talk about Spring Framework, I would really look at it from three different perspectives, right? Architecture, design, and your programming or coding. And other than that, we can also talk about the different features of Spring Framework, the different Spring modules which are present, and also about the different Spring projects which are present. These are all the important things that we would need to cover when we are asked any question related to any of this stuff you are seeing on the screen right now. You can choose any of those things which you are really comfortable with. For example, when I talk about architecture, one of the important things that Spring support is very, very flexible architectures. Earlier, we looked at multiple layers in a web application, right? So web layer, data layer, as well as your business layer. Let's take the web layer, for example. Spring has good support for struts, as well as Spring has its own MVC framework. The fact that I'm using Spring does not restrict the choice I have with web MVC. So I can still use struts, or I can use Spring MVC, or I can use any other thing. For example, if I want to use JSP for views, Spring has good support for it. If I want to use FreeMarkup for views, even then Spring has good support for it. For example, if I want to use aspect-oriented programming, then Spring supports basic aspect-oriented programming by itself, but it also has good integration with aspect-oriented programming framework like AspectJ. So that's very important. I mean, when I'm talking about something from an architectural perspective, I want to have the flexibility. Using the Spring framework should not reduce the amount of choices I have to develop my application. That's one of the most important features of Spring Framework. It does not really restrict any of your choices when I'm making use of the Spring Framework. Next, from the perspective of design, we already talked about tight coupling, loose coupling, how Spring promotes applications to have good loosely coupled design. So because of the loosely coupled design, you'd see that our code would be very easy to unit test. So whenever I would want to write a unit test, because we have designed the application in a loosely coupled way with all the dependencies demarcated really well, you'd see that whenever I develop an application with Spring, it's very easy to unit test it. Whenever we're talking about popularity of Spring Framework, I think these are the most important reasons. I mean, very, very flexible in terms of the architecture, helps in designing loosely coupled applications which can be easily unit tested. Different features of Spring which enable these features are dependency injection, IOC container. We also already talked about auto wiring and component scan. The other thing you can talk about when such questions are asked are talk about Spring modules, what are the different modules you have worked with and things like that, and also talk about the different Spring projects that you have worked with. In this video, we took a quick look at how to answer questions related to big picture with respect to Spring Framework. Things like, what do you think about it? Or why is it popular? Or can you give a big picture of the Spring Framework and things like that? Until the next video, bye-bye. Welcome to this section on MVC, Modal View Controller. In this section, we would talk about web applications and how you develop web applications with Spring MVC or Spring Web MVC in particular. Let's start with questions related to architectures of web application. We'll talk about Modal 1 architecture, Modal 2 architecture, and Modal 2 front controller pattern. So what is Modal 1 architecture? Modal 1 is the most basic of web application architectures. What happens in Modal 1 architecture is in your browser, the request which comes from your browser would directly go to a JSP. So whenever the action which you put for your form in the browser would be a JSP page. So the request from the browser would directly go to the JSP. All the logic would be in the JSP to handle that. I mean, you'd be directly calling the database, you'd be populating the model, you'll be able to create the view. Everything happens inside the JSP. The thing about the Modal 1 architecture is the fact that there are no servlets which were present at that point in time. All that was used was JSP. So the Java server pages was the only thing which was handling all the logic. And therefore, this architecture resulted in very complex JSPs, which were very difficult to maintain. Because JSPs had all the logic for managing the entire application, these kinds of applications were very complex to maintain. And we quickly migrated to something called a Modal 2 architecture, where the request first goes to a servlet. So what happens is from the browser, the request goes to a servlet. And the servlet makes sure that it gets the right data from the database, gets the model ready, and then redirects it to the view. And the view makes use of all the data from the model and shows it on the screen. So this was one of the first really clear separation in terms of MVC, Modal View Controller. So we had a model which represents the data from the application, and we have a view which is like the JSP or the FreeMarkup templates, which are used to show the content from the model. And we had a C, which is the controller. These servlets acted as the controller. So they used to, so if there is a request coming to a servlet, the servlet would make sure that it gets all the data from the request, make sure that it's stored to the database, it retrieves the data that is needed for the next page, gets the model ready for that, and then sends it to the next view so that the view can be rendered. So further enhancement of the MVC pattern is the model to front controller pattern. In the front controller pattern, instead of the servlet getting the first request, all the requests would first go to the front controller. The front controller is the one which gets all the requests. It makes sure that the response is ready and it would send it back to the browser. The front controller pattern is very important because now I have one place to control everything that comes from the outside world. So let's say if I want to make this application secure, I can implement security at the front controller level. So if I make sure that the front controller is secure, then my entire application below it is also secure. That's the flexibility that
In this chapter, we're going to talk about dependency injection. Before that, let us try to understand the term tight coupling. Let us take a look at some of the real-world examples of tight coupling, thereby you'll understand better. So here, from this image, we can say that the pillars and the building are both tightly coupled to each other. That's because, later that I found out that the pillars are getting old, let us try to understand the term software component. Just as we have a car that method that is specific to cat, which is shout. Now this is a very simple example to make sure that they are loosely coupled to each other, not tightly coupled to each other. So let's continue from next video and see the solution. In our previous example, we've seen and the method name in the rest of the code would also change with the method name make noise. Now that way, I have the freedom to switch to alternative. For example, if I make this to cat, okay, let us take a look at how we can perform dependency injection using Spring Framework. Download the project that is bundled along with this chapter and import it into your workspace. I believe Spring Context is dependent on Spring Core, so even if you don't specify it, Maven is actually going to take care of downloading Spring Core because Spring Context is dependent on it. And once you do that, just right-click on the project, go to Maven, and click on Update Project. Only then will the Maven look for all these libraries in the internet and download them into your local repository. Once you do that, you have to create an XML file. You can give any name of your choice. In my case, it's with the name config.xml, and this XML file must reside under the resources directory. And this is the XML file, which is a key file where we would define all our classes. In the eyes of Spring, every component or a class is called a bean. So we just simply defined all the beans that we're going to work on. And here is how you would define them. I've specified the class name, which in this case is dog, and I've given it an identifier with the name animal. Similarly, I've also defined our bean in here, including its package, and then the dependencies. In this case, the bean is dependent on the bean animal, and so application context is going to take care of injecting animal into this bean class. And right after that, we're going to use this object context to get the bean from the browser. It would enter some details, and those details will be sent along with the HTTP request to the front controller. And then the dispatcher servlet will delegate that call to the controller logic using the handler mapping. And then after that, finally, we will render back some result by using a view resolver. So let's take care of the step one next. But in this prompt where you have to choose but we're seeing an error because we don't have the Servlet API in the class path. So let's try to introduce the Servlet API as well as the Spring libraries required for our project. And the way we're going to do that is by opening this file called pom.xml file, stands for Project Object Model. And if you're not used to Maven, the first of which is the Spring Core, which will enable all the Spring Core functionalities, and the other is the Spring Web MVC to create web applications. Along with that, we're also going to be including the Servlet API library. Once I add all these tags inside our project, let me copy it and paste it inside the dependencies tag. I'll do Ctrl-Shift-F to give proper indentation. And then after that, let me also add the following property in here. Well, I could actually copy this version everywhere, but the reason why I had to separate it out is because at the moment I'm using release 5.16 for all the Spring libraries, and that's about it. The beauty with Maven is that Maven is not only going to download these particular libraries, but also the jar files that these libraries rely on. So it will just simply download everything end to end that your project ever need. And with for this purpose, I'm actually going to create a new package. By the way, by default, you don't have the Java folder inside the Maven project. We need to create one. So I'm going to create a new Java folder. And this is where let us talk about the web application context in Spring. Whenever the server starts, it will take the value. The server knows that it needs to pre-initialize the dispatcher servlet. And the job of dispatcher servlet is not only to divert the calls to a relevant controller logic, but prior to that, it needs to create so-called a web application context, inside which we'll have the instances of all the beans that are declared in the config file. The dispatcher servlet would be able to identify this file with the following name, dispatcher, which is the name of the servlet. Let's talk about various different mapping annotations you can include as part of the controller class or controller logic. First, let's talk about the request mapping annotation. The request mapping annotation is the generic annotation, meaning that whatever the URL pattern that you specify as an attribute is applicable for all HTTP methods. So be it a GET request or POST request, it doesn't matter. The annotation is applicable for all those cases. However, if you would like to get more specific and target only a specific HTTP method, then you can have the following syntax. You just have to add an additional attribute telling the method that you want to target. So in this case, we are just targeting only the GET request and would like to map for the following URL pattern. However, this is old way of declaring this annotation. In the recent versions of Spring, we now have more specific annotations specific to each HTTP method. We have GET mapping, which will accept only GET requests. Similarly, we have POST mapping, PUT mapping, delete mapping, and patch mapping. If you're using web browser, then only these two annotations would be relevant. Browser is not capable of sending other types of requests like put, delete, or patch. However, if you're using RESTful web services, then definitely other methods will come into picture as well. In RESTful web services, GET would mean that you want to retrieve a resource or a database entry. POST would mean insert a resource. PUT would mean you want to replace a resource. Delete would mean, just as the name suggests, you want to delete a resource. Patch would mean you want to partial update a resource or an entry in the database. Since we're not concerned with RESTful web services at the moment, we're only going to focus on these two annotations. In fact, we're going to take a look at a very good example by creating a very simple application. And by using these annotations does not mean that we're going to neglect the request mapping annotation. In fact, the perfect design practice is to have this annotation added at the controller class level and then get more specific with these annotations at method level. Once we take a look at how we write our example application, you'll have a better picture on the same. Here is the application that we're going to create. Imagine that you're given with the project of creating an application wherein when the user visits the website, the user must be able to design his or her own t-shirt. So this is the home page of our application. And when we click on design, which is a link, we're going to send a GET request to a controller logic wherein we're going to populate some data, which will then be sent back as a model data to this view technology in order to render all those details. In this case, we would let the user customize the t-shirt by selecting all these options, including the name that he wants to give to his t-shirt. And this time I have chosen Thymeleaf as a template engine, just so that we can touch on all those view technologies that are popular with Spring. Once the user chooses all the required customization, the user would then click on proceed, and we're going to send a post request to yet another method inside the same controller, and that method logic would just simply write back the text. Basically all the options that the user had selected in the previous page. Down the line, as we progress through the course, we're going to introduce some additional modules inside our application, one of which is going to be a database. so that we can actually store the data into the database and do some processing. But for now, this is how our application is going to look like. Once we have a project walkthrough, you'll understand things in much. Let's take a look at how our application is written. This is our application's homepage. Whenever somebody visits our website, this is the first page that they come across with. This is a very simple page that has one image, which is basically our company's logo, and then a piece of text. And then we have one link, which when clicked, would take the user to this custom design page where the user can actually design their t-shirt, giving it some name. So let's take a look at what's happening in the code. Our home page is written inside index.html page, and when you name the file as index, that's going to be detected automatically as a home page. I mean, you don't have to introduce a controller just to handle the home page request. It will be detected by default. And inside this file, we just simply have a very simple HTML code with image, text, as well as one link. The link would point to this resource /design. So we have introduced a controller to handle that very request. So I've used this annotation request mapping and provided the URL pattern. And in our case, this URL pattern would map with the request when somebody clicked on this link. And since by default, HTML links or GET requests, the request would land inside this method. Since it has this annotation get mapping, we can also have an attribute, a URL attribute, just as in here, inside this annotation as well, but there is no need for it right now. But if you were to add something like this, for example, say test, then your URL has to be design/test. Only then will it land inside this controller method. Let's undo those changes. By the way, in order to make our application visually appealing, I've also introduced the cascading style sheets. You don't have to introduce this if you're creating this application from scratch. This is just to make our application look better. I'm going to make this project available for you to download anyway so that you can experiment with it. What we're doing inside this method is pretty straightforward. Since we don't have a database, we're explicitly populating the model data, but ideally we would be fetching all these details from the database. And what I'm trying to do here is I'm just trying to add a few attributes with key value pairs. The key is going to be the string, and the value is going to be an array list of strings, which will basically describe all the customization options. So user can customize with the color of the t-shirt, size, sleeves, as well as the collar style. And each one have their own corresponding values. We're populating these details because we want to populate all this data on the UI, because that's what user is presented with. And as I mentioned before, we're going to be using Thymeleaf template engine to do this job. And in addition to adding this attribute, we also created an object. Let me explain. So when the user selects various different options and clicks on proceed, we need something that will hold all the entered or chosen details. And when he clicks proceed, we'll do some processing with that data. So for that purpose, I have to introduce another class, which is a simple POJO. It has one string attribute as well as list of strings. Basically what this means is the user will enter some name to their customization, and that name will be held by this string attribute. And all the rest of the choices that the user will choose are going to be stored as a list inside this attribute. So we have to create an empty object of it and send it as an attribute so that we can use it inside our template. So let's take a look at the Thymeleaf template that's going to populate this page. And here it is. The key element here is this form with the method post. We're using post request because we want to keep all the user entered data secure. I mean, if you're using get request, then all the details can be seen inside the request. If you're using post, all the entered details would be part of the request body, which is more secure. So once the user enters some data, let's say test, and I'm going to choose one color as well as the size. And once we click proceed, we have a handler method for that inside the same controller class, but with post mapping annotation. And inside this, we're trying to receive the object that we had populated. And inside this form, in order to take the user input, here we had to use some TimeLeaf specific stuff. For example, we have TimeLeaf value, which would map with this tname. So we have to provide the exact same name in here as well. Just try to pause the video and try to understand what's going on in here. It would look very obvious. And we're using TimeLeaf for each. And inside select, we're going to populate all the list of options available. I mean, whatever the list we're populating here, we just want to loop through them and sort of populate all of them as a list. And so we're using this particular attribute, pheach. This is equivalent to for each in Java. And we're populating all the options available inside the color attribute. Again, just pause the video and try to understand. This would look obvious. Similarly, rest of the elements were also populated. And finally, we have the submit button that would